frequency distributions. Now what this is just a way to arrange data values into a chart that can be easily understood. What we're going to focus on are the classes and the frequencies. Sometimes the classes will be given, sometimes only one of them will be given, only stipulations will be given, it just depends. We're going to look at the widths, the model class, and the midpoint. Now these may not make any sense as you read the definitions, so we're going to do an example to help us out. Now you're given, in this first example, you're given these data values, and you're asked to make a frequency distribution using classes that having widths of 10, and the first class begins with 60. So what I'm going to do is I'm going to make a chart. And I probably need to do something else first. Let's just do this. We'll do classes, and then I do a tallies column, and then the frequency column. And so, when we look at these numbers, it looks like they consist of 60s all the way up to 90s. So, and you're told that the first class begins with 60, and there's a width of 10. Well, what that means is, some people think it goes from 60 to 70, and then your next class would be 71, or start with 71. Well, that's not correct, because if you subtract 71 minus 60, that equals 11. For it to be the class width, it must equal 10. So what that means is that we must, if we start 60 on this class, then we must start 70 on the next class, because 70 minus 60 is 10, which means the first class is 60 to 69. So what that is, it's just saying that if you were to count from 60 to 69 by 1, 60, 61, 62, 63, 64, 65, 66, 67, 68, and 69, there'd be 10 total values there. That's what the width means. So probably the easiest way to think of it is, it's just if you subtract the lower limits of the classes, they should always equal 10. So that means the next class will be, or the upper class, or the upper limit of the second class is 79. So the next class would be 80 to 89. Once you start it, it's pretty obvious to see, in this case, what the classes are. Since I don't have any numbers big and then past the 90s, these are the only 4 classes that I need. Now this tally column isn't really necessary, but I like it because it's like a record keeping column. Here's what I mean. Starts at 63. Mark it off, because that goes in the 60s class. 78 goes in the 70s class. So we're just marking tallies. 65 goes in the 60 class again, so now I got 2 tallies. And 89 is in the 80s class. 90s in the 90s class. 99 is in the 90s. 87 is in the 80s. 98, 75, 90, 80, 87, 65, 97, I'm going to put a line through there, that makes 5, 60, 89, put through there, that's 5, 79, 74, 85, 97, 86, 82, 92, 94, and 71. So when you add up the tallies, you have 4 for the 60s, 5 for the 70s, 8 for the 80s, and 8 for the 90s. Now I like to do to count all these, make sure that we're correct. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 25. So when I add these up, 9, 8, 17, 17, 8, 25. Just make sure that we at least looked at all of them. I didn't leave anything out. I don't really need that 25, but I'm going to keep it there just in case you need it for something. So the next question is find the width and midpoint of each class. So I'm going to come over here. This is not part of the frequency distribution. I'm just going to use it in column form just to make it a little bit easier to write the answers down. That's all this is. It's not part of the actual distribution. We want to find the width and the midpoint of each class. Well, we already know the width of each class. It has to be 10. Well, I guess the way you read that is it's asking for the width of each class. Well, it was given to be 10, so it's actually a question that was already given to us. Now the midpoint is way more important. To find the midpoint, what you do is you take, for this first class, 60 plus 69 and divide that by 2. If you need to take a calculator and type that in, let's just do it. 60 plus 69 divided by 2. And that's 64.5 for the first class. The next class will be 74.5. And the next one will be 84.5. And the next one will be 95.5. One reason is because since the width is 10, if you add 10 to each one of these, you get the next class. Or next midpoint, I should say. And you can just go ahead and just do the averages of each if you want to, which is going to be the same thing as the first class. Just start the 7. So that's how you get the midpoint. Midpoint's the same as average. Now you're asked to find the modal class. So the modal class is a class that has the most number of data values. In this case, there's 2 of them. There's 2 classes that have 8 in them, and so that's these classes. So 80 to 89 and 90 to 99. I think in this book you're allowed up to 2 modes, so that's what we'll go with. If not, then there won't be any modal class, but I think you're allowed up to 2. Just depends on the textbook. So that's pretty much what all this was. So mode means the one that occurs most often, has the most frequencies, or the biggest frequency, one that occurs most often. And let's just do another one just to make sure we know what's going on. This time you're not told what the width is, so we got to figure it out. So let's start with classes. Tally. And then the frequencies. Or frequency, however you want to write it. But you told the first class is 2.3, 3.1. Now what that means is my next class will start with 3.2. So we need to find out what is 3.2 minus 2.3. That's 0.9. And it never hurts to show you what that is with the calculator. You don't want to make a mistake with this. Hate to do it over. And so, let's see. We have 7s. What's the biggest number? I'm looking for the biggest one. So far 7.6 is what I see. So 7.6 is the biggest. So I need to keep on going until I find a number that has 7.6 in it, or a class that has 7.6 in it. So what that means is I'm just going to keep on adding 0.9 to each of these. So 3.1 plus 0.9 is 4.0. Because like I said, with the widths, they always go in equal increments from the lower limit of one class to the lower limit of the next class. So we're going to add 0.9 to 3.2. We get 4.1. Then you add 0.9 to 4 and you get 4.9. Add 0.9 to 4.1. You get 5. Let's use 5.0. And then add 0.9 to 4.9, you get 5.8. I'll show that just so you see. We're going to keep on going with our classes. 5.0 to 5.8. 9. I'm going to keep on going this way because I think it's easier. 5.9 plus 0.8, 6.7. Let's add 0.9. 7.6. That's as high as I need to go, because 7.6 is the biggest number we have. So let's just go ahead and take the 5.8 and add 0.9. We get 6.7. That's always good to do both sides, because if you look up there, I miscounted. So did y'all catch that? So it's always good. This is actually a good way to do this, because you can catch your own mistakes like I just did. So you got 5. Let's go back to 5.9, and we'll add 0.9. That's 6.8. And then add 0.9 again. See, it's a good thing I did, because I don't actually need this last class, because it's going to be too big. Be no reason for it. So let's just take the 6.7 and add 0.9 to it. 7.6. Since that's the biggest number, I don't need to have another class. So, you see my mistake that I made? It caught. The way I did this, I was able to catch that mistake. If I did it another way, I may not have been able to catch it. So now we can do the tallies. So start the 2.3. That goes in this class. 2.8 is in this class. 3.1 is also in this class. 4.1 is in this class. 5.2 is in that class. 7.6 is in this class. 5.4 is in this class. 5.8 is in this class. 7.2 goes here. 3.9 goes there. 7.3 is there. 7.2 is there. 3.9 is there. 2.8 there. 2.5 there. 4.8 there. 4.9 there. 4.4 there. 5.4 there. And 3.3 goes there. So if you add those up, we have 5, 3, 4, 4, 0, and 4. So the modal class would be 2.3 to 3.1, because that's one that occurs most often. And that's pretty much all the frequency distribution is. Now this one up here, we might come back and use it quite a bit, so I'm going to erase some of the stuff that we don't need. So let's look at some other graphs. One example is a circle graph. Typically when you're given a circle graph, first off, all the percentages have to add up to 100. So you always want to make sure, and if they don't, then you put it in another category. But typically you're given a circle graph with percentages like this, and you're just asked a question. So it says find the number of motorcycles. Well, this graph represents a total of 7,321 vehicles. So how many of those are motorcycles? So when you look at this, and you look at the circle graph, you find the motorcycles, and the percentage is 11%. So the percent of motorcycles is 11%. So when you convert that to a decimal, you get 0.11. To find the number of motorcycles, you take 0.11 times 7,321. And so that's 0.11 times 7,321. And which is round the nearest whole number. So that's 805 motorcycles. And that's pretty much it for that example. Histograms. Histograms are nothing but connected bar graphs. And the horizontal axis has the classes, and then the vertical axis has the frequencies. And for the most part, we're going to use the midpoint of the classes to label our horizontal axis. So If you look at this, you see these numbers 63, 78, 65. We've already done it. So we've already done our frequency distribution, which is what you would do first. And so we're going to draw like the first quadrant of the XY axis. And over here we put the frequencies. And down here we're going to put the classes. Now let's go back up here. And we're going to use the midpoints. So we have 64.5, 74.5, 84.5, and 94.5. So what we're going to do is we're going to act like we're going to crunch all this together and start with 64.5. It's like from 0 to 64, or 0 to 60 has been crunched. That's what kind of that means. So we're just going to label midpoints in order, just like we would if it were an x-axis. And we're going to look up here again and see that their highest frequency is 8. So on my y-axis, I can count my ones or twos. Let's just count my ones since it's so small. Try to be as even as we can. 1, 2, 3, 4, 5, 6, 7, 8. So what are the values? 4, 5, 8, 8. So here we go. Run them over here. The frequencies are 4, 5, 8, 8. Since this is the midpoint, we're going to try to get this as in the middle of our bar graph. So it goes up to 4. Something like that. And the next one is a 5. So we're going to go up, start here, and just go up 1, and then go over. And we're using the midpoint. Next one is 8. So let's take this side and extend it up to 8. And the last one is 8 also. So let's just keep it there. Make our connected bar graphs using the midpoints. That's not so bad. And then the last example is the draw frequency polygon. Well, that's nothing but a line graph. And we're going to label it the same way as we did the histogram. So we're going to put the frequencies over here. Classes down here. I'm going to crunch them up. Start at 64.5. And then 74.5. 84.5. And 94.5. Use the midpoints. Count by ones. 1, 2, 3, 4, 5, 6, 7, 8. And it was, what was it? 4, 5, 8, 8. So 64.4 was at 4, so I'm going to put a dot there. 64.5 was a 4. 74.5 was a 5. Put a dot there. 84.5 was 8, so put a dot about there. Same for 94.5. So we're just going to connect the dots. Now, depending on your book, sometimes these will do, they'll like bring it down. Yours may or may not. It just depends. Depends what class you're taking. And that's a frequency distribution, circle graph, histogram, and a frequency polygon. And we have one more graph to look at, the stem and leaf display. The stem, well, let's just do one you want to. So put the stems over here and the leaf over here, depending on the book that you're using. They may look like this, they may do something like this. We'll just do this. Now the leaf is the rightmost digit. It's always in the right column. The stem is all the other digits. So we're going to get double digit numbers. So if you look at it, we have single digits up to 23. So what that means is this 8 is like a 0, 8. So I'm going to start the stem as being a 0, and then 1 and 2. So let's start. So we have this 8, we have another 8, another 8, another 8, another 8. No big deal, because that's actually 0, 8, 0, 8, 0, 8, 0, 8, 0, 8. Now we have a 1, 10. Now this 10, we already have the 1, which is the tens place. The 0 goes in the leaf. It's like the ones place. We have another 10. So put another 0 there. Got another 10. Put a 0 there. Put another 10. Put another 0 there. Because that's the tens place. And now these are the individual ones places. So that goes 10, 10, 10, 10. We have a 15. Already got the 1. So put a 5 over here. We have another 15. Already have the 1. Put another 5 over there. Have another 15. Already have the 1. Put another 5 over there. Then we have an 18. So the 8 goes there. 18 again, another 8. 18 again, another 8. 18 again, another 8. 18 again, another 8. 23, oh, can't put it there because the 2 is over here. So the 23, the 3 goes over here. Another 23 goes there. Another 23. Another 23. And the last value, 23 again. That's what you call a stem and leaf display. Several different types of graphs we looked at today.